Today, we're jumping into the one paper from 2017 that pretty much set the stage for all of modern AI. It's a wild story, really, about how a little hack designed to fix a problem ended up becoming the entire solution. And yeah, it's the reason things like ChatGPT can even exist.
So, to really get why this was such a huge deal, we first have to look at the problem everyone was stuck on. We need to understand the old way of doing things and why it was so incredibly flawed.
All right, so before 2017, if you were working on language AI, your go-to tool was something called a recurrent neural network, or an RNN. And, the name kind of gives it away. They process everything in a very rigid step-by-step order.
Think about it like this. Imagine you're reading a really long, complicated sentence. As you read each word, you're trying to keep a running summary in your head, right? You read word 1, make a note. Read word 2, update the note. That's pretty much exactly what an RNN was doing.
It's a strictly one-at-a-time process. Each word just updates the single, growing summary of what the sentence means. And the whole idea was to cram the meaning of an entire sentence into that one final package, which, as you can probably guess, created a massive, massive problem.
Yeah, trying to squeeze all that information through one tiny point creates a serious bottleneck, especially with longer sentences. Honestly, it's just like a digital game of telephone.
For the very first word in a sentence to have any impact on the very last word, its meaning had to somehow survive that entire sequential journey. And let's be real, most of the time it didn't. By the time it got to the end, the original context was just fuzzy, weak, or totally gone.
And that's really the heart of the issue. The network just forgets. It has a terrible time connecting a word at the beginning of a paragraph with a related word way at the end. It just loses the thread. So, naturally, the community came up with a little fix.
Researchers built this mechanism that was, it was kind of a hack, but it was a really brilliant one. They called it attention, and its whole job was to give that forgetful RNN a little help.
So, instead of just relying on that one final squished summary, the attention mechanism gave the model a kind of superpower. At any point, it could take a shortcut. It could literally look back directly at any word in the original sentence to grab the exact context it needed, right when it needed it. And look, it was a huge improvement. Models got way better, but it was still just a patch. It was a clever feature bolted onto that slow, clunky, sequential system. The RNN was still forcing everything to happen one single step at a time.
And this is where the whole story just flips on its head. The researchers over at Google looked at this attention hack and asked a question that was so simple it was actually revolutionary.
They saw this clever little shortcut and thought, wait a minute, what if this attention thing isn't just a patch for the old system? What if this could be the new system?
And that led them to the title and the core idea of their paper. They proposed this totally new architecture that just threw out the sequential RNN model. Instead, they built a system that was based only on attention. And they called it the transformer.
So, how in the world does this new model think if it's not going step by step? Well, this is where it gets really, really cool. Instead of that linear, one word at a time assembly line, you can think of the transformer as being more like a super sophisticated database. It can look at all the information from all the words all at the same time.
It does this with three main concepts that it generates for every single word: a query, a key, and a value. Now, the query is basically the model asking a question. The key is like the label on a file folder. And the value? That's the actual information inside that folder.
So here's how it plays out. For any given word, the model might generate a query that asks something like, hey, what's the verb here? It then takes that question and compares it to the label, the key of every other word in the sentence. When it finds the best match, it grabs the value, which gives it all the juicy context about that specific action.
And here's the absolute genius of it. It does this for every word simultaneously, creating this incredibly rich web of connections. It's not a straight line anymore, it's a network where every single word can talk directly to every other word.
Okay, so why was this such a game changer? Moving from a single path to this giant interconnected web, what did that actually do?
Well, with the old RNN, information had to travel down this long, winding road. With the transformer, the path between any two words in a sentence is always just one step. It's a direct flight. And shorter paths mean less information gets lost. It is really that simple and that profound. This one change was, well, transformative. Since it wasn't sequential anymore, you could process everything in parallel, which let us train way bigger models on way more data. This is what allowed AI to finally understand context across entire articles, not just sentences. It became the blueprint for almost every large language model we have today.
When you boil it all down, this story is a perfect example of how the biggest breakthroughs don't always come from adding more stuff. Sometimes they come from having the courage to remove a core piece that everyone else thought was absolutely essential. It was a total paradigm shift, all born from one simple question, which really makes you wonder, what's the next fundamental piece we think we need that we actually don't?